In the previous day's work, we meshed a existing 12-tooth gear into a 60-tooth gear. What this accomplishes is every time this small gear turns one full rotation, it just barely turns this larger gear a little bit at a time. So what you accomplish with that is torque. Now, if you wanted speed, you would just change these motors out, switch their position so that every time the motor made one revolution, it would spin the smaller gear many times. In this case, I believe it is 5 times. So we have a 1-to-5 gear ratio for torque with this particular orientation, and it does torque um, this gear way down, so it would move very slow, but it would have a lot of power. Today, we're going to move away from that gear and go back to finishing up our previous attempt at a wheel, a drive wheel, and we'll also need a shaft collar on that. So we're going to use the 4-inch diameter wheel, and we'll drag that into position today. Once you have the 4-inch diameter wheel in place, you will also need a shaft collar to cap that off. So once again, I like to move everything close to my work area as close as possible so that I can zoom in and see. We need a shaft collar to cap that off at the end. So those are just the two pieces of assembly that we'll be working with today. And we're going to zoom in close enough so that we can see the work that we need to do. Close out the data panel so that we have more visibility of the work area. And we'll also rotate Now we're going to create a joint based off of this circular point on the wheel right here. And we will match it to the circular endpoint of our drive shaft. And zoom out just a little bit so that we can set this slider right here and give ourselves room for a shaft collar later. Press enter when you're done. And of course you can see that the tread came loose from the wheel. This happens because it was not set as a rigid group. So we're going to undo that operation, and we will change our rotation just a little bit. And we will use this particular item from the browser, from the assemble menu, and say rigid group. So that locks all of those components together. If we say OK to that operation, and then zoom in enough to repeat our last attempt at a joint, we're going to use the same two joint origins, and you'll notice the difference right away. Once we bring the slider back just a little bit, press enter, it moves the tread, the entire wheel at the same time. So finally, to put a shaft collar on the end of this, we will join again and base it off of the same center point and move into the shaft. Use a slider to bring it up to the edge of the wheel. Change from a revolute back to a rigid because you want that shaft collar to be locked tight onto the drive shaft. Press enter when you're done, and that would complete today's work. Once you have on screen the same thing that I'm displaying right now, I will check you off.